After you enter or upload your data, click on the Run Segmentation Analysis button in the upper left corner to begin the analysis. When you click on the Run Segmentation Analysis, a number of analysis options will be presented. Check the Advanced option. Then you will see that Ingenious can run either hierarchical clustering analysis or k-means clustering analysis. Recall the differences between hierarchical clustering analysis and k-means? Hierarchical clustering builds a hierarchy of clusters, and it does not require any assumption on the number of clusters. The results of hierarchical clustering usually are presented using a dendrogram. By reading the dendrogram, we can get a sense of how many clusters we will end up with based on the data we have. K-mean clustering analysis does require the specification of the number of clusters in the analysis. Therefore, normally, before running the k-means, we will run the hierarchical clustering analysis first. Select hierarchical clustering and uncheck the force number of segments. The report shows that a 3-segment solution is identified. Let's do a quick review on how to read the dendrogram. First, find a big jump on y-axis, and we can draw a horizontal line somewhere here. This line was cut by 3 vertical lines, pointing to the same conclusion that a 3-segment solution is optimal. Well, Ingenious directly tells us the optimal solution in the report. Even if you don't know how to read dendrogram, you can get the right solution. However, in many other analysis tools, you need to read the dendrogram by yourself to figure out the optimal solution. Now let's go back to the dialog box. This time, let's select k-means, check the option of force number of segments, and put the number 3 in the box. Next, select the appropriate data block for segmentation data and descriptor data. A checkbox under the segmentation data section allows you to choose whether to standardize data. This option scales all variables to 0 mean and unit variance before the analysis. Choosing this option is recommended if you have measured the variables on different scales. The Data Transformation drop-down under the Segmentation Data section allows you to select a method to pre-process the data. First, None option. This option indicates you want to use the original data. Next, Standardization by column. This will standardize the data by column, variable, so that columns measured on different scales become comparable. Next, Standardization by row. This will standardize the data by row, respondent, so that data will be measured as a deviation from each respondent's average response. This method is only valid if variables are already measured on the same scale. Next, Box-Cox normalization. This will apply Box-Cox normalization to the data, which reduces data skewness and the effect of potential outliers. Last, factorization. This will transform the data using factorization, and then segment them, weighted, factor loadings instead. This will remove smaller factors, for example, noise, from the data. In this example, we measured each variable using the same scale from 1 to 10. We can use the original data. Select the None option. After selecting all the options, click the Run button found at the bottom of the Segmentation Analysis setup window to begin the analysis. By default, the report will output as a web page. Let's select Excel. You will see a pop-up indicating the segmentation analysis is underway. Your report will output in the format chosen.